Hello everyone, I'm Ganesh Sarang in Shri Venkateshwara College of Engineering. Today I'll be taking up the topic dynamic programming using knapsack problem. So moving on to the topic. So what is this knapsack problem and what is memory function? So the knapsack problem is a classic optimization problem in computer science that involves selecting items with different weights and values to fit into a limited capacity knapsack. So here dynamic programming and memorization techniques are the powerful tools for solving this problem efficient. Dynamic programming approach to the knapsack problem. So first is the subproblems. The key to solving the knapsack problem using dynamic programmers is to break it down into smaller subproblems, each of which can be resolved or solved independently. Next thing is the tabulation. The solutions to the subproblems are stored in a table, allowing the overall solution to be built up in a systematic way. Next is the optimization. By considering the optimal solutions to the subproblems, the dynamic programming approach can find the overall optimal solution to the knapsack problem. Moving on to memorization and tabulation in the knapsack problem. First one is a memorization. So here it is a technique that will store the result of expensive function calls and also returns the catched result when the same input occurs again. Next thing is a tabulation. So tabulation is a bottom-up approach that will build a table of solutions starting with the base cases and working up to the final solution. Next is the comparison. So both this memorization and tabulation, these are the powerful techniques for solving the knapsack problem with their own strengths and trade-offs. Moving on to the Warshel's algorithm for transitive closure. So here, what are the different steps followed in Warshel algorithm is, first thing is to initialize a matrix to represent the direct connections between the nodes. Step 2 is to iterate through the matrix, updating the connections to include transitive relationships. Step 3 is the final matrix that will represent the transitive closure of the original path that has been traversed. Moving on to Flood's algorithm for all page shortest path. So how this will be followed is, the first step, initialize the matrix that will represent the direct connections between the nodes with the distance values. Next step is to iterate through the matrix, updating the distance to find the shortest path between all the pairs of nodes. Step 3 is the final matrix, which will represent the shortest path distance between all the pairs of nodes in the graph. So moving, what is the difference between the Warshall's and Floyd algorithms, or the comparison between these two algorithms? So Warshall algorithm is basically used to find the transitive closure of a graph which is a set of all the nodes that are reachable from each other. Floyd's algorithm, it is used to find the shortest path between all the pairs of nodes in a graph, which is useful for problems like network routing and traffic optimization. What are the similarity and differences between these two algorithms are? So both the algorithms are dynamic programming techniques, but they solve different problems and have different time complexities. Moving on to the applications of knapsack problem and memory functions. First application is the resource allocation. So here, the knapsack problem is useful for optimizing the allocation of limited resources, such as in the logistics, supply chain management, and project planning. Next thing is the combinational optimization. So here, memory functions like the memorization and tabulation are essential tools for solving complex combinational optimization problems, including the knapsack problem. Third thing is computer science education. So here the knapsack problem and associate algorithms will be basically or commonly used in the computer science education to teach how dynamic programming actually works and also how to get into the different problem solving techniques. Next thing is real world problems. The knapsack problem will have applications in various real world domains such as finance, transportation, and even in video game design. So what is the conclusion that is obtained from dynamic programming or the knapsack problem? So here optimization, basic thing is optimization. So it is a fundamental optimization problem with many real world applications. So dynamic programming, so such as memorization and tabulation, these are the powerful tools to solve the knapsack problem and other algorithms. Next thing is algorithms, Warshall's and Floyd algorithm. These are the important graph theory algorithms with distinct use cases and characteristics. Next one is the computer science. So here the knapsack problem and associated algorithms are the functions that will be used in the computer science education and research. Thank you for watching.